this is the solution to problem 65 from section 6.2. And it states a steel plate has a form of 1/4 of a circle. And we're given a diagram. The radius of the circle is 60 centimeters. And they're going to drill two 2-centimeter holes in the plate. And they show us the location of the holes. And the coordinates of those holes are given as x1, y1, and x2, y2, respectively. And we're asked to find the coordinates. So one way to approach this problem is to use special right triangles. So I'm going to draw in 2 right triangles. So I'm drawing one in now in red. And if we look at this right triangle, we're dropping in an altitude. We see that the angle on the bottom left is 30 degrees. That means the upper right one is 60 degrees. So we have a 30, 60, 90 triangle. And if we remember, in a 30, 60, 90 degree right triangle, if we label our side lengths, if the side opposite the 30 is labeled as A, the side opposite the 60 degree angle is A rad 3, and the hypotenuse is 2A. In this particular problem, we know that the hypotenuse is on this little dashed circle, and that dashed circle has a length of 56. So the hypotenuse here is 56. So and for our triangle, 2A is 56 centimeters. And from that, we can figure out that A is half of 56, or 28. And the third side opposite the 60 is going to be 28 rad 3. And so if we look at this triangle, I'm going to label those lengths on here. 56 I did as the hypotenuse. The side opposite the 30 is 28. And the side opposite the 60 degree is 28 rad 3. And then if we look at these coordinates, 28 rad 3 is actually x1. So I can label this coordinate here. This is going to be 28 rad 3. And y1 is the vertical distance, which is 28. You could also solve this using sine and cosine. If you do that, you'll get a decimal approximation for 28 rad 3, which is 48.5. And the y-coordinate is still 28. We can do a similar analysis now using a different triangle, dropping in an altitude from the second hole. So I'm drawing that triangle in blue. Once again, the hypotenuse of this triangle is 56. And I'm going to draw this triangle here, which is a right triangle, hypotenuse 56, but now the angle on the bottom left is 60 degrees, meaning the angle up top here is 30 degrees. If the hypotenuse is 56, the side opposite the hypotenuse is, the side opposite the 30 degree angle is half the hypotenuse, so that would be half of 56, which is 28, and the side opposite the 60 would be 28 rad 3. Once again, using A, 2A, and A rad 3 as our relationships in a 30, 60, 90 right triangle. And now we can label our x2 and x1 coordinates. So x2 is now the horizontal distance, which on this triangle is going to be 28. And the y2 is the vertical component here. This is actually y2 is this length, which is 28 rad 3. So that's the second coordinate. If you write that with a decimal approximation, you'll get that x2, y2 can be thought of as 28 and 48.5. That's x2, y2.